Okay, so good afternoon, second session of arbitrage theory. Okay. And first of all, okay, I will remind what we have introduced as notation in the previous session, okay, to be clear with the notation at the beginning, okay? So keep in mind that I have tried to model a financial markets, okay, and I have introduced two types of assets. A non-risky one, that is just an asset adapted to my filtration, okay, and the risky asset. The condition on the non-risky asset is just that I want its values to be strictly positive, and you are going to understand why today, okay? So we have introduced notations concerning the vector of prices, okay? I have introduced ST at, that is a stochastic process with values in R to the power D plus 1, okay? So I have D plus 1 component, where the first one is the value of the non-risky asset at time t, S0t, and I suppose it to be strictly positive in the definition of the non-risky asset, and then I have the prices of the risky assets. Okay, so it's the notation I have introduced, ST at, that is a vector with D plus 1 component representing the prices of the assets. Okay, are we able to see here? Yeah. Perfect. Okay. So I have this plus 1 assets, okay, and I have introduced the notion of financial strategies. Okay, and financial strategies are just things that are related to the construction of financial portfolio. And in the same spirit, okay, if I want to define a financial strategy, okay, I can define an RD plus 1 values stochastic process, where the first component represents the quantity of non-risky asset I have in my portfolio at time t, okay, and the same for the D-risky assets. And I have introduced a supplementary notation that is to denote by HT, okay, and not HT at. HT is just the vector of the quantity of risky assets I have in my portfolio. Okay? HT is a vector with D components representing the quantity of risky assets I have in my portfolio. Okay? So in particular, okay, so a financial strategy is a vector or a stochastic process with values in R to the power D plus 1, okay, and I suppose it to be adapted to the filtration, and, okay, intuitively, HI of T represents the quantity of the ICE risky asset, of the ICE asset I have in my portfolio between T and just a little bit before T plus 1, okay? So I have defined the value in this situation. And what is the value? But it is just the scalar product between the quantities and the prices. Because I have done some hypotheses, okay, the non-friction hypothesis in the market. I have no transaction costs, no dividends, okay, so the value may be defined as the scalar product between the vector of quantities and the vector of prices. Okay, so I have a sum here, a sum over D plus 1 component. Okay, and I have denoted by V0, okay, the initial investment. Okay, V0 was the initial investment. So in the 2-day session, okay, we are going to start to speak about arbitrage strategies. And before to to go to the arbitrage strategies, okay, I need an intermediate notion that is the notion of being self-financed. That's why I have introduced the consumption process, okay, in the previous session. So what was the definition of the consumption process? Okay, so I have defined the consumption process as T at T belonging to 1 capital T, that is defined in this way. Minus Ct at is equal to what? It's equal to the value of the portfolio at time t minus this one. Minus this one. So what is the meaning of this definition? I consider two consecutive instances, t minus 1 and t. Okay? What I have denoted by, so I have this one, yes. You have t minus 1 and t here, okay? What I have defined as ht minus 1 is in fact the quantity of asset I have here. Because keep in mind that I work in discrete time, so it happens nothing between t minus 1 and t, okay? But intuitively for me, ht minus 1 will represent, excuse me, it's a mistake here, it's meaningless this one. Huh? Yes, because here I have a vector with d plus 1 components, and here I have a vector with d components. So here, ht at. Okay? So it's the quantity of asset I have between t minus 1 included, and t excluded. So if I have this time square in mind, what are these quantities here? So I have a portfolio constituted at time t minus 1. So I have my portfolio, and just a little bit before t, the price will change to pass from st at minus 1 to st at. So this is the value, okay, of my portfolio just a little bit before t. Okay? So this is the value of, if you want, the old portfolio. If I consider old here and new here, old before t, new after t, okay? So it's the value of the old portfolio at time t when the prices pass from st minus 1 at to st at, okay? So this is this one, value of the old. And what happened at time t? At time t, you change the composition of your portfolio. So you pass from ht minus 1 at to ht at. Okay, you change the composition of your portfolio. And this change will be at the prices given by what happened at t, that is st at. So that's why I have here what I have called the value of the new portfolio. And what I define as minus the consumption process is the difference between the value of the new and the value of the old. Meaning that when this quantity is positive, okay, the value of the new is greater than the value of the old. Okay? Implying that Ct has to be negative. Okay? Because if my new is greater than my old, it means that I have invest in order to form the new portfolio. In the case where this difference is negative, it means that the value of the old is greater than the value of the new, okay, and so that my consumption process is positive. It means that I have consumed something because the value of the new is less than the value of the old. Okay?
So negative consumption is investment?
Yeah. You inject some money, okay? Positive consumption, you subtract money or value, and negative, you inject. So do you have a question concerning this, or it is clearer now?
Concerning financial strategy, self-finance.
So, it's my next step, okay? So I have defined the consumption process here, okay? I have introduced a new family of financial strategy, the one that are self-financed. And what is the definition of being self-financed? It means that the consumption process has always be equal to 0. Okay? So your question is about what? The intuitive meaning of this?
Yes, what is the goal of that?
Yes, what is the goal of this one? So, what is a self-financed financial strategy? It's a strategy, okay, that may be done with a consumption that is 0 at any time. What is the meaning of the consumption is 0 at any time? So of course, it doesn't mean that I do nothing. It just means that at any time, when I reorganize my portfolio, I can do this, but I have to respect the budget constraint. I can invest more than what I have, and I can't invest less than what I have. Okay, so typically, a self-finance strategy is a strategy that when you have invested an amount of money at time t equal to 0, you can do it without investing more and without, okay, consuming anything. Okay? So for this kind of strategy, if you spend €1 at time t equal to 0, you won't have to spend anything, okay, or to consume anything in order to make it across time. Okay? So this is the definition of something that is self-finance. So of course, when I see this definition, okay, keep in mind that VT hat is defined this way here. It's HT hat, ST hat. If you do nothing, meaning that this one is equal to this one, of course, my consumption process is equal to 0. But it's not possibility. Okay, so when you do nothing, you are self-financed, but the interesting self-finance strategy are the one where you reorganize your portfolio, but just respecting the budget constraint at any time. And you are going to understand in a few minutes why I need this condition, because when we are going to define what is an arbitrage strategy, that is a kind of miracle strategy in the market, if I don't exclude, okay, the strategy that are not self-financed, it's really easy to build an arbitrage strategy. Okay? So arbitrage strategy will be the special case of self-finance strategy, and I will explain why just after. Okay? So self-finance means that once you invest at time t equal to 0, okay, you can do your strategy without investing and without consuming. Okay? And of course, you can win, you can lose, depending on the variation of the assets and what is your strategy, okay? But to do it, okay, you don't need to invest and don't need to consume. Is it clear for everybody? So it is for discrete time, okay? But you will see with Mr. De Meyer in continuous time that you will also work, okay, with self-finance strategy. The only problem you have in continuous time is that my reasoning is not possible, because here I have a time and the time after. Okay, in continuous time you don't have a time and the time after. And I will explain to you in 2 minutes, okay, what may be the analogous of the definition of a self-finance strategy in the continuous case. Okay? So it's what I have done, okay, during the previous session. Okay. So we are going to see some consequences of being self-financed, in fact, to begin with, okay? The first result we are going to see is the following. A priori, if I want to characterize perfectly a financial strategy, I have to tell you what are the quantities of all the assets, okay? At any time. But in the case of self-finance financial strategy, I said the following. So it's the lemma 1. Okay, lemma 1 that tells me that a self-financed financial strategy may be characterized by the initial investment, okay, by the consumption process, and by the quantities of risky assets. So I repeat that. A priori, if I want to characterize a strategy, I have to tell you at any time what is the quantity of the risky and the non-risky asset I have in my portfolio. Okay? I said that, excuse me, stupid what I have written here, because I have the consumption process here, so if it is self-finance, okay, my consumption is 0. So let's say the following, a financial strategy. I have anticipated my next remark. So a financial strategy may be characterized by the initial investment, the consumption process, and the quantity of risky assets. That is something that is equivalent to the knowledge of the quantity of risky asset and the quantity of the non-risky asset. Okay? So as a consequence of this one, I can write it directly. It's corollary 1. And it's what I had in mind, okay, when I have written self-finance in the previous lemma. The self-financed financial strategy is characterized by, if I am self-financed, I know that the consumption process is 0. So I can remove it from the previous characterization, and I just need the initial investment and the quantity of risky assets. Okay? My initial investment and my quantity of risky assets. And if you want, okay, it's another argument in order to answer your question, because you see that when you are self-finance, you don't need to know what is the quantity of non-risky assets. It is a byproduct of the definition of being self-finance, because when you reorganize your portfolio, since at any time you have to respect the budget constraint, it means that the quantity of non-risky assets can't be independent of the quantities of risky assets, because okay, at any time you need to have an equilibrium in substance. Okay. So if I am self-finance, okay, I can just give you the initial investment and the composition of the portfolio in terms of risky assets. I have no more at here, okay, and it is sufficient to characterize the things perfectly. Okay. Yeah.
Why don't you use the price of the asset?
I don't know the price. If I knew the price, okay, I won't be there, okay? I will be at home with a cocktail, okay, doing nothing, okay? I am not able to anticipate, okay, what will be the price. And keep in mind that what I mean is that it's my composition of the portfolio that I want to describe. This one, okay, I know ST at only at time t. It's not possible to anticipate what will be ST plus 1 and so on, okay? ST. ST. I take my financial decision at time t using the information at time t. Okay, so if I want to change my portfolio today, I will use the financial information today. That is, I will know what will be S0 t at, S1 at, and so on until ST, but not using ST plus 1 at because I don't know it. Okay? And I just said that a priori, if I want to characterize my strategy, okay, I have to describe at any time what will be the composition of my portfolio in the non-risky and the risky assets. I say that an equivalent way to do this is to give you initial investment, the consumption process, and the quantity of risky assets. And in the case of a strategy that is self-financed, okay, I can restrict myself, since this one is 0, to the initial investment and the quantity of risky assets. Okay? So the proof of the lemma, not that complicated, okay? But what we are going to see that if I know this, I know exactly everything. In particular, what I know, I will know the composition of my portfolio in the non-risky asset. It is, if I know the quantity of risky assets, okay, I have to deduce this one, from this one and this one, the quantity of non-risky assets. Okay? So, at time t equal to 0, what is the definition of the initial investment? The definition of the initial investment is just the scalar product between the quantities of assets and the quantities of, and the prices of assets. Okay, so I have this one is H0 at S0 at. I can write this way. I can separate, if you want, the non-risky assets from the risky ones. Okay, so I obtain this way H0 0 S0 0 at plus what? But this one, the sum from K equal to 1 to D H K, excuse me, H K 0 S 0 K at. And I see that when I am at time t equal to 0, I can express the quantity of non-risky asset in my portfolio at time t equal to 0 from the preceding line, that is this one, okay, minus the sum from k equal to 0 to d divided by S0, 0. So it means that when you are, so let's write it very short. So when you are at time t equal to 0, if you know the initial investment, if you are at time t equal to 0, it means that you know the values of the asset at time t equal to 0. Okay? So if I give you the initial investment and the composition of the portfolio in terms of risky assets, you are able to deduce what it means you at time t equal to 0, that is the quantity of non-risky assets in your portfolio at time t equal to 0. So if I give you this information, okay, at time t equal to 0, you are able to deduce what you have in your portfolio in terms of non-risky asset at time t equal to 0. Okay? I continue. So it's for time t equal to 0. At time t strictly greater than 0. But I have the definition of the consumption process here. Okay? I have the definition of the consumption process. I have minus Ct at, that is equal to the value of my process at time t, minus Ht minus 1 at St at. So minus Ct at is equal to what? So when I am at time t, okay, what I know? From my hypothesis, I know the consumption process. I know the value of the assets at time t. I know also what happened the time before, okay, when I am at time t. So I have just to develop this term in order to make appear the quantity of non-risky asset in my portfolio at time t. So what I have here? I have H0, excuse me, HT0, ST0 at, okay, plus the sum from K equal to 1 to D HT K ST K at, and minus HT minus 1 ST at. And what you can do from this line here is to extract HT0 equal to something that is just a basic algebraic manipulation of the previous line, okay? And what you need to keep in mind is that what you know at time t, I know the consumption process by hypothesis, I know the value of the non-risky asset when I am at time t, I know also the quantity of risky assets by hypothesis, okay? I know the value of the risky assets at time t. I know this one because it is what happened for my portfolio the time before, okay? And here I have missed the at. And at time t, I know the values of the assets. Okay, so the only thing I don't know is the one I want and the one I can extract from the previous information. So to summarize, in order to characterize what will be a financial strategy a long time, okay, you will need to precise at any time what will be the quantity of assets you will have, non-risky and risky, or equivalently, you can only precise what will be the quantity of risky assets, the consumption process, and the initial investment. Okay? And for a self-financed financial strategy, since I know that the consumption process is zero, it will be characterized by its initial investment and the quantity of risky assets. Because I repeat, the quantity of non-risky asset will be a consequence of the value of the other quantities. Is it clear? So what we are going to do now, okay, is to specify a little this one. We are going to see a nice formula concerning the value, okay, of the self-financed financial strategy. But before to do this, we are going to introduce the notion of actualized value. And now we are going to remove the at, okay, as I have promised you, okay, during the previous session. Do you have some question? No? Okay? So characterize knowing all the quantities or equivalently knowing this triple here. In the case of self-finance, I can remove this one because by definition, when I am self-financed, consumption is zero. Okay? So if you don't have question, I erase everything. Okay? And we are going to introduce first a notation in order to remove the ats everywhere. Okay? And we are going in the second step to specify, okay, what is the form, okay, of the value of a self-financed financial strategy. And as you are going to see, of course, this value will be something that will depend only on the initial investment and the quantity of risky assets. We won't have in the formula the quantity of non-risky assets. Okay? In accordance with what I have written. So may I erase? No questions? So I repeat that I take time to erase because the quality of the video depends a lot on the way you erase the board, in fact. So we are going to introduce in definition 3 the notion of discounted values. Keep in mind that I have made a distinction between the non-risky asset and the risky assets. For the non-risky asset, okay, I have said that its values has to be strictly positive, and I have said to you that I suppose this because in the future, that is today, I want to use it as a numeraire. Instead of expressing values in euros or dollar, for example, we are going to express anything in terms of quantities of non-risky assets. Okay, so the non-risky asset will be a benchmark for us, okay, in order to compare the value of financial quantities at different dates. Okay? So it's exactly what I introduced here. So it's the definition 3. Okay? It's the definition of discounted values. Discounted values. So it's new notations, discounted values in order to actualize, okay? And the idea is to make disappear the at in the notation previously introduced, okay? Okay, so write it this way. For all k belongings to 0, 1, d, for all t belongings to 0, capital T, I define st of k as stk at over st0 at. It's the value divided by the value of the non-risky asset at this time. It's what we call the discounted value. And you will see that from now on, okay, we are going mainly to work with discounted value. That's why, okay, we had to support this notation at for 3 hours, but from now on, okay, we will remove it. Okay? It's better than to do the contrary. Okay? So I have this one. So it means that instead of expressing the price, okay, in euros or dollar, okay, I express it in terms of quantities of risky non-risky asset at the same time. Okay. So in particular, what you can say about ST0. The discounted value of the non-risky asset is 1. If I express the price of the non-risky asset in terms of quantity of non-risky asset, it's always 1. Okay. I have this one. Okay. So I introduce this one, and also VT, the value, so the discounted values of a portfolio at time t will be just the value at time t divided by S0. Okay? So instead of expressing my value in dollar or euro, once again I express everything in terms of quantities of non-risky assets. Okay, another notation. I denote now by ST. Okay, previously I have defined ST at as S0T at, S1T at, SDT at. Okay, a vector with D plus 1 component. Now, ST is just a vector with only D components, that is just S1T, SDT. In fact, I remove the first component because I know it to be equal to 1. Okay, so I don't need to include it inside. And now I have a coherence between my notations, because keep in mind that when I have defined a financial strategy, okay, I have defined it with the notation HT at, and I said that HT represents the quantities of risky assets. And here, ST will represent the vector of the risky assets prices. Okay? So D components representing, okay, the discounted values of the D risky assets. Okay? So just notations. And from now on, okay, we will work using these discounted values. Okay? And that's why I have imposed for the non-risky asset to be strictly positive at any time, simply to be able to divide by its value. Okay. Lemma 2. So we have seen in corollary 1 that a self-financed financial strategy may be characterized by the initial investment, okay, and the quantities of risky assets. Here we are going to specify a little these results, okay? So it's an equivalence, so it's an equivalent characterization of being self-financed. A financial strategy is self-financed if and only if for all t belonging to one capital T, Vt is equal to V0 plus the sum from k equal to 0 to t minus 1 of the scalar product between hk and sk plus 1 minus sk. So you have a nice expression of the actualized value of a self-financed financial strategy. And you see, of course, that in this expression, you depend on what? You depend on the initial investment, and you depend on the quantities of risky asset. H is the vector of size D, having inside the quantities of risky assets at time k. And you see that, in fact, the value of a self-financed financial strategy, okay, that comes from the, and in fact, only the fluctuation of the risky assets and not from extra investment or consumption. Okay, so it's what we are going to prove. Just a remark and a little notation. From now on, okay, I will define HST as this term here. The sum from k equal to 0 to t minus 1 hk sk plus 1 minus s. So why I introduce this notation? But just in order to lighten, okay, the sum here, the way to write the sum, but also because you have here, if I want to make the relation with what you will do, or what you are going to do with Mr. De Meyer, you have here something that can be assimilated with a discrete stochastic integral. A discrete stochastic integral. Why I call it discrete? Because, okay, here you have inside the expression only the increments of the prices of the risky asset, or actualized prices, okay, between the two instances, okay? And you will see that the way to build the stochastic integral, so what you are going to build with Mr. De Meyer is something like this, okay? Where here you will have the quantity of risky asset in your portfolio in continuous time. Here you will have, okay, the prices, the actualized prices of risky assets, okay? And in fact, it's a kind of analogous of when you discretize, okay, a Riemann integral, you obtain a Riemann sum. You will see that when you discretize this kind of integral that we call the Nito integral that you are going to define with Mr. De Meyer, okay? When you discretize, you obtain these kind of things that are the analogous, let's say, of Riemann sum in the case of the stochastic integral. Okay. Okay, so I have this one. So I continue my remark before to do the proof. We continue with the analogy in continuous time. If I suppose this expression to be true, that is, I am self-financed, something that is equivalent to this one, okay, I can say that Vt plus 1 is equal to Vt plus 1 term. So you see that at any time you add one term in the sum, okay? So if I do the difference between the actualized value between t plus 1 and t, I obtain something like this. That is ht st plus 1 minus st. And I see that my actualized variations, that is, I can write it this way, my actualized variations between two consecutive instances, okay, only depend on the variations of risky assets and of my strategy at time t, okay, in terms of risky assets. Okay, so you have here the variations of the actualized value between t plus 1 and t, and here the variation of the prices of the actualized prices of risky assets between t plus 1 and t. Okay? Now you will see that if I come back to the initial definition of self-finance I have given to you, it's not possible to transpose it in continuous time because, okay, there is a time and the time that is consecutive, okay? But you will see that this condition that is totally equivalent to being self-finance, if I suppose my lemma 2, but I can adapt it in continuous time, okay? And I can write that, so in continuous time, if I want to have the analogous of such a thing here, but I can write it this way. I will replace an increment by an infinitesimal variation, that is d of Vt equal to what? Ht d of St. And when you will deal with finance with Mr. de Meyer, we will see that one possible way to define what is to be self-finance for a financial strategy in continuous time is to use this one. So of course, my analogy between increments and infinitesimal variation is something that is intuitive. You will give sense to this one with the notion of Ito differential. In fact, here the Ito differential, Okay? So just to tell you that even if, okay, the two frameworks will be different because one is in discrete time and the other one in continuous time, okay, but they are not that far. In fact, you have, of course, analogy between them. Okay? So if you don't have a question concerning my remark, I will do the proof of the lemma 2. Questions? No? Please? Questions? Okay? So let's do the proof of this one. Okay? So it is an equivalent, so a priori I have to prove two things. Okay, but we are going to see that I will prove one side, and to obtain the converse, okay, I will just have to start from the end and come back to the beginning of the proof. Okay? So maybe I will erase this one, okay? And do the proof of the lemma. Okay, we are going to do this implication. Okay, so my hypothesis is to be self-finance, and I want to prove that the value is given by this one. Okay, so first of all, I remind you that I have defined the value as, okay, the sum of the product of the quantities times the prices. Okay? So I have this one. I can write it this way. It's H0T S0T at plus, okay, something that I have written like this, okay, it's the sum from K equal to 1 to D, H T K S T K. I have this. If I want to express this quantity in a discounted way, so I am something at time t, I just have to divide by the value of the non-risky asset at time t. So if I divide by the value of the non-risky asset at time t, Vt at becomes Vt. Here I have simplification by S0t at, so I have this one is equal to H0t plus the sum from K equal to 1 to D of H T K S T K. And using my previous notations, the sum, shh, please. If you have some question, ask me. Okay, I am paid for this, so don't worry about this. I will try to answer. Okay. This one may be written in a compact way using the notation I have previously introduced, because what I do here, I do in fact the scalar product between the quantities of risky assets and the discounted prices of risky assets. So I have here H, okay, HT, okay. So in conclusion, what I have written is that Vt is equal to H0t plus HT. For the moment, I have done nothing. I don't have used my hypothesis. I am self-financed. For the moment, I use nothing. I just come back to the definition of the value and express it in a discounted way, introducing the notation I have previously, or using the notations I have previously introduced. Okay? So for the moment, I just express, okay, the discounted value. Okay. I have this one. So now I use my hypothesis. What is to be self-financed for a financial strategy? The consumption process is equal to 0. Okay, so keep in mind that minus Ct is equal to Vt at minus Ht minus 1. This way at St. Okay? So if I am self-financed, I am equal to 0. Okay? And so, if I am self-financed, Vt at is equal to Ht minus 1 at St at, something that I can develop, writing that this is equal to H0 T minus 1 S T0 at plus something like this, that is, write it this way, the sum from K equal to 1 to D of H T minus 1 K S T minus 1 K at. So this is the self-finance condition. So be careful, it's not the same as this one. Here, it's just the definition of the value that is true for any kind of financial strategy. What I write here works for self-finance financial strategy. Okay? So I have done a ICU, okay? right? It's st here, okay? Not st minus 1. So if you have some remark, tell them, okay? So I am on the board, sometimes I can do misprints, okay? It's natural, okay? Because I have a big board and I am a few centimeters away, okay? So here it's a t, okay? Not a t minus 1. If I express this one in a discounted way, that is, if I divide by the value of the non-risky asset at time t, I obtain Vt that is equal to what? H0 t minus 1 plus the sum from k equal to 1 to d of h t minus 1 k s t k. Something that I can express this way. So be careful, huh? Here I have hats and here I have no more hats, okay? Because I deal with my notations and discounted values. Okay, so I am not very far from what I want, okay? So I have my Vt that is equal to this expression. It is a consequence of being self-financed, okay? And I know that, keep in mind that the value is this one for any t, okay? But in particular, if I come back to this expression of the value that is true for any type of financial strategy, I can write it for t equal to t minus 1. If I write it for t equal to t minus 1, I have the right to do. I have h0 t minus 1 plus h t minus 1 s t minus 1. And so I can extract h0 t minus 1 from Vt minus 1 and this scalar product. And if I plug this one inside what I have here, I obtain, so I repeat, h0 t minus 1 will be extracted from what I have obtained here. And I obtain what? So I will write here. I keep the statement on the board here, but I continue my proof below. So here I have h0 t minus 1. I use the expression obtained here, that is Vt minus 1 minus the scalar product here. And so if I do this, Vt is equal to what? H0 t minus 1, that is Vt minus 1 minus Ht minus 1 St minus 1. Okay, so it's H0 t minus 1 plus this scalar product, that is plus H t minus 1 St. And using the binarity of the scalar product, I obtain that Vt is equal to Vt minus 1 plus what? H t minus 1 St minus St minus 1. And if you have understood what I have done, it's finished. Because what I have done, I have proved that I can have an induction relation between Vt and Vt minus 1. That is Vt minus 1 is equal to the scalar product. If I want to express Vt, I just do the sum of all the expression from 0 to, or from 1 to t. I will have simplifications, okay? So from this induction relation between Vt and Vt minus 1, I deduce that the Vt is equal to V0 plus the sum of all these terms, okay, from t equal to 0 to t minus 1. and it's the end of the proof for my implication. So I repeat what I have done, express the value, the actualized value in a general term, okay? This is true for any kind of financial strategy. I use the self-finance condition in order to obtain this expression for the actualized value, okay? That is here, okay? And now, using what I have obtained in the left part of the board for H0 t minus 1, I replace inside, I obtain this expression, okay? And I see an induction relation between Vt and Vt minus 1, from which I deduce the value of Vt at any time. So be careful, because in this statement, okay, or even in this proof, you have add that disappear when I actualize, and you have also add that disappear because here, okay, I only focus on quantities of risky assets. Okay, they disappear from my computation. Yes.
Pour le bottom, il faudrait plutôt HK, SK plus 1 moins SK.
No. Ah.
Oui, en haut c'est marqué, et là...
Yeah, you're right. Why? Because here, okay, I have t minus 1, t minus 1, you're right. Thank you, okay. So I can write it this way, so it will be here, right? Sk plus 1 minus Sk. Okay, if I do the sum of all these terms, I obtain this one. Thank you. So I have this. So just to remark, if you have understood the proof I have done, in fact, I have also proved the other implications. Why? If I start from this one in order to prove the fact that I am self-financed, okay, you start from the end, and then you will come back to the beginning, okay? So I have done the proof in one side, okay? If you take my proof, start from the end and come back to the beginning, you have the proof of the other implication. Try to do it at home. But really, okay, you just have to copy what I had done from the end to the beginning in order. So you start here, you come back here, having this in mind, okay, and you obtain that from this one, I have the self-finance condition. Okay.
Please.
Yeah?
You got the expression from VT by return.
Here? You can do, if you want, you can do an induction, or you can do the sum of this term for t from, you do the sum of all this relation, okay?
By returns, yeah.
But you can do an induction if you want, okay? You can also directly do the sum of all this expression, and you will have simplifications, changing the index in the sum. Okay? But you can do the proof by induction if you want, properly, okay? If the difference is equal to this one is equal to the sum of all these terms. So I repeat, take care of this proof at home, okay? Because it's not that complicated, but be careful with the notation. It's a good exercise in order to handle the notation of the course, okay? Other questions? No? So I have the value of a self-finance financial strategy that may be expressed this way, and I repeat that. You see that the value depends only on the initial investment and the quantity of risky assets. Okay, I don't need the quantity of non-risky asset, because the quantity of non-risky asset is a byproduct of the self-finance condition. Okay, so if you're okay, I erase everything. No more questions? It's okay? So from one course to another, okay, it's very important for you to have a look on what we have done. Huh? I have notations and so on, okay, so if you just come to the course, okay, without reading what we have done previously, okay, it will be not really efficient. So now let's speak about arbitrage opportunities. Because the first main part of this course will be to give a characterization, a probabilistic characterization of the absence of arbitrage opportunity. The fact that we don't want arbitrage opportunity. And so first, let's define what will be for me an arbitrage opportunity. Okay, so it's the part, if I am okay with my notation, it's the part 0.3. So arbitrage opportunity that I will denote from now on AO. Arbitrage opportunity. Okay. So first the definition of what is an arbitrage opportunity. It's my definition for okay. First of all, an arbitrage opportunity is something that is self-financed. Okay. So a self-financed strategy is an arbitrage opportunity if three things are fulfilled. First, I start from zero. Okay? I start from zero. So I do a financial strategy starting from zero. So it means that, for example, I borrow some money to the bank, okay, or I do a short sale to do this, okay, as we have seen together. I start from zero. I never lose, okay. I am always greater than what I have initially invested. It means that I never lose money. Okay? It's not sufficient to have what we call an arbitrage opportunity. And finally, the probability to be strictly positive is strictly positive. So what is the meaning, the financial meaning of this one? So I start from nothing. At capital T, I never lose money. And here it means that, so I can put a hat here for the moment, I have real opportunities of profit. That is, the probability that I win money is strictly positive. It's what we will call an arbitrage opportunity. Yes?
It's also a capital T.
Yeah, it's a capital T. Okay? Between 0 and capital T. I start from 0. At the end, that is at capital T, I never lose money. It is that I am always greater than my initial value. And then the probability that I am strictly greater than my initial value is strictly positive. So with words, I repeat, I start from 0, I never lose money, and I have real opportunities of profit. Okay? Just to, yeah?
Didn't you say that that it should be superior or equal to 0? Superior or equal, the probability that we had t would be superior or equal to 0?
I know, if you put equal here, you have 1 from this one. Huh? So keep in mind that here I write, okay, relation dealing with,
Probability of 1.
just answer to your question. The two first line here, okay? When you write relation between random variables, you know that this one means that the probability that V0 hat is equal to 0 is equal to 1. Here, the probability that Vt positive is equal to 1. Okay? It's equivalent to say this. Okay? But the last condition is a real condition. I am always positive in the large sense, but I want me to be strictly positive with a proba that is strictly positive. So it means that I don't want to be always equal to 0. Okay, I don't want to be 0 with proba 1. Okay, if you are positive with proba 1 in the large sense, it doesn't imply that you have the third condition. Suppose that you are always equal to 0 here. It works with this condition and not this one. Okay? So it is what we call an arbitrage opportunity. Just, yeah.
But you know, to put it another way, the probability that V hat T would be negative is strictly 0. Right?
No? Well, you are not negative here.
But it's a probability would be 0, so there's no probability of
No, you are.
loss.
The probability that you are strictly negative is for sure 0, because it's the complementary set of this one. So you have a portfolio that starts to 0. You want it to be always positive at the end and strictly positive with a proba that is strictly positive. Of course, you don't take strictly negative values. It is forbidden by this second condition here. So just a remark concerning this, okay, P and P, okay, probability 1. In general, it's what we call, okay, V0 hat is equal to 0, P almost surely, Vt hat positive, P almost surely. But just keep in mind what were my hypotheses at the beginning of the previous session. So keep in mind that I have omega that is a finite set here. Okay, omega is a finite set. And I have defined a probability P such that P of W is always strictly positive for all W in omega. Okay? Why I remind this just before? Because the meaning of this one, in fact, so to be 0 with probability 1 or to be 0 everywhere in this situation, it's something that is equivalent. Okay? To say that a property is true with probability 1 or that a property is true everywhere, it's equivalent in my situation here. Because I have a finite number of points, all of them being with a probability that is strictly positive. Okay? So that's why at the beginning I have removed this one, okay, but keep in mind that it is totally equivalent here. Okay, you have a total equivalence between property true everywhere and property true with proba 1 from my framework. It's not true, for example, in the course of Mr. de Meyer. Yeah. Okay. So this is the definition of an arbitrage opportunity. I start from 0, I never lose, and I have a real opportunity of profit. And we will see that, in general, we don't want such strategies to be possible in a financial market. Because, okay, you have a strategy that is not all the time a winning strategy, but you never lose and have real opportunity of profit. Okay? I don't want this possibility on a financial market that works correctly.
Okay. Even if it is without friction?
Yes, if you have some friction, sometimes you may have, okay, but in general, you know the classical argument concerning arbitrage, okay, we say that if it exists an arbitrage in the market, you will have one operator that will remark it, that will take benefit, and by the law of supply and demand, it will disappear. In general, it's what happened in the real life, because you have financial operators that are paid to detect such strategy. So it means that, in fact, they exist, but for a short time, because okay, you have professionals that detect them and take benefit and make them disappear. So it means that for you, okay, you won't be never, you never be able to take benefit of such a thing if you observe it in the market. Okay? So just a remark. Have you understood why self-finance is important here? If I characterize an arbitrage opportunity as a kind of miracle strategy, self-finance is very important in my definition. Because what happens if self-finance is not in the definition? But suppose that you have a strategy, you start from 0, and at the end you invest €1. You have a strategy starting from 0, and where at the end you have €1. But it's not a miracle strategy because you have invested €1 at the end. By this condition, I mean that at any time I don't have the right to consume or to invest more than my initial amount of money. Okay? So self-finance is very important, okay, in order to give intuition about this definition. If you remove self-finance, okay, there exists such strategy in the market, okay? You can create value investing more than what you have invested initially. So this is the definition of an arbitrage opportunity. So some remark about this definition. So is this definition okay? Or do you have some questions before I do my remarks here? Okay? Everybody? I repeat that for French students, you can ask questions in French if you don't want to speak English. Okay? So remarks. I see that in this definition, I have the probability P, the probability P, the probability P. Okay? So I have a definition that depends extensively on my historical probability. But if you remember what I have said at the beginning of the previous session, I have said that in practice, I don't know the historical probability. Okay? I don't know precisely what is this probability. So I have a kind of problem, okay, because I have a definition depending on something I don't know. Okay? So something that is not very satisfactory. First remark is the following one. If I replace in the preceding definition P by the probability Q equivalent to P, the definition remains the same. Is it clear for everybody? So I said that in my definition, I can replace P by any other probability Q equivalent to P. I remind you what is the definition of our probability to be equivalent to another one. Okay, here Q is equivalent to P if and only if P of A equal to 0 is equivalent to Q of A equal to 0. Meaning that two probabilities are equivalent if they have the same negligible sets, the same set with proba 0. Okay? So is it clear for you that if I have this, my definition is not changed if I change P into Q here? So you can take picture, but you will have the videos of the course. Huh? You can take picture, but...
I just cannot see this where I take picture, you know, not
But you have some places here, huh? I know that you are very far from the board, so. Okay. So I repeat, is it clear for everybody that if you change P into Q in my definition, I have the same definition, in fact? So why? I have the same set with proba 0. So if I have the same set with probability 0, it means that two things. I have the same set with proba 1, taking the complementary, so it means that these two conditions will be the same if I change P into Q, because same set with proba 0, so same set with proba 1. And also, if I have the same set with proba 0, I have the same set with proba that are strictly positive. And so, I have the same set with proba 0, so I have the same set with proba 1, and so I have the same set with proba that are strictly positive, and so the definition doesn't change if I change P into Q. And for us, I repeat, it's really important because a priori, I don't know P. I will see in my course that I will have other kind of probability that will be interesting for us in order to compute the prices of financial assets based on my risky assets. Okay, this probability Q will be known explicitly. Okay, and so this definition, in fact, is not that strange. Okay, because it doesn't really depend on P. It just depends, okay, on the class of equivalent of the probabilities. Okay, I have this one. I continue my remarks. Here, I have expressed everything in terms of value using the at. Okay, I have said to you that I have introduced the discounted values in order to remove the at. Okay, so it's possible to remove. So if I denote this set of hypotheses by star, I can say that star is equivalent to what? But to say that V0 is equal to 0, that Vt is positive, and that the probability that Vt is strictly positive is strictly positive. I have this because I have supposed that the values of the non-risky asset are strictly positive. The values of the non-risky assets, are strictly positive. So I can express this condition with or without the discounted values. Okay. So I have this. So I have an analogous definition using the discounted values. Other equivalent formulation. Keep in mind that we have seen together that Vt is equal to V0 plus what I have defined as HST. That is the sum, okay, from k equal to 0 to t minus 1. Okay? In my situation here, V0 is equal to 0. So Vt is equal to the discrete stochastic integral. It just means that here I can replace this by this one. It's just playing with the notations I have previously introduced. I have this one. So I said nothing, I just use the previously introduced notation. Okay? The last one, V0 is equal to 0, H S capital T positive, expectation under P of H S capital T strictly positive. why I have the last equivalence. Why I can replace this one by this one. So I repeat my question, why, okay, this condition is equivalent to this one.
The expectation will be a sum of positive terms.
Yeah. But I have something that is more general, okay, in terms of proba. Are you okay with this? You're okay with this? Okay. So if I take for x n01, the Gaussian distribution with mean 0 and variance 1, okay, you tell me that the expectation is 0 and so the random variable is 0. Doesn't work. This. I have one side that is obvious, okay, if I am 0, my expectation is 0, no problem with this side. But if my expectation is 0, a priori I am not necessarily equal to 0. Depends, sometimes, but not in general. If I want to have a general result, I need to impose the sign of capital X. For example, if X is positive P almost surely, then I have this. Okay? If I am positive, my expectation is 0, equivalent to I am equal to 0, P almost sure. Okay? It's exactly what I have here. I work with random variables that are positive. To say that I am 0 is equivalent to say that I am equal to 0, P almost surely, so equivalently. Not to be equal to 0 in expectation means that I am not 0. And what is the meaning of not being equal to 0 for something that is positive? That the probability to be strictly positive is strictly positive. Okay? So this one equivalent to this one from this little result concerning probability. Okay? Let's do the break if you don't have questions. Questions?